In this video, we are going to discuss some important facts about the higher order linear differential equations with constant coefficients. What do we mean by the solution of a differential equation? So for example, let's say if I have this equation, okay, and I'm saying that y is equals to cos x is solution of this. That means this will satisfy my equation. So let's check. Dy over dx is what? That is minus sin x. D square y over dx square will be cos x with negative, right? Now if I place these values here, what is d square y over dx square? That is cos x. And what is y? Y is this cos x equals to 0. So we are getting this thing. So this is satisfying my equation. That means y is equals to cos x is a solution of this, right? So we must know about the dependent solutions and independent solution. Okay. So what are the dependent solutions? Dependent solutions are those solutions which can be generated by the help of independent solution. For example, cos x is independent solution. By just multiplying this with 2, I will have 2 cos x, and you can check 2 cos x will also satisfy your equation. Similarly, you can take minus 1 by 3 cos x. That will also satisfy your equation. Okay, so these two are actually dependent solution because we can generate this by using cos x only. By just multiplying this with some of the constants, we can generate this, right? Similarly, we have another solution for this equation, that is sin x. Okay, sin x is the another solution, but this is independent. We cannot generate sin x from the cos x. Okay, let's check whether sin x satisfies your equation or not. Okay, so if I take y is equals to sin x, what will be dy over dx? Dy over dx will be cos x, and what will be d square y over dx square? That will be minus sin x. Now just substitute this value here. So what will you get? Minus sin x plus sin x. Okay, this is satisfy my equation. So that means sin x is also solution of this, right? So we have two independent solution, and what are those solution? Cos x and sin x. These two are independent solution. Why so? We cannot generate the cos x by using sin x, okay, or by just multiplying sin x with any of the constant. We cannot generate cos x. Similarly, we cannot generate sin x by just multiplying this with some of the constant. Okay, so these are the independent solution. But if I say 2 cos x plus 3 sin x, you can check this will also satisfy your equation, but this is the dependent solution. Why so? Because we can generate this solution by just multiplying this thing with 2, this thing with 3, okay? And constant, these constant are the free elements. We can take any constant, okay, and we can just multiply our independent solution, and we can just take the linear combination of that, okay? That will again satisfy your equation, but these solutions are the dependent solution. Okay, on the basis of this we have some important points which we will discuss on next slide. So first point is the complementary solution of the differential equation consists the same number of arbitrary constants as of the order of differential equation. Means if you are having differential equation d square y over dx square plus y equal to e power x, let's say. So here in the complementary solution you will get two constant because order of this equation is 2. Okay, so this is the meaning of first point. You can learn how to find the complementary solution by the previous video. I'll put the link in the description box. Now what is the second point? Second point is there are same number of independent solution as of the order of the differential equation. So whatever the order of differential equation they have given, same number of independent solution you will get. For example, if you have d square y over dx square plus y equal to 0, this equation, you will get two independent solution. We have already seen that was sin x and other was cos x, right? So these are the two independent solutions. So point number 3. Point number 3 says the function along with the each constant in the complementary solution of higher order differential equation with constant coefficients are actually the independent solution. So for example, if we have this equation, again I am taking the same one, d square y over dx square plus y equal to 0. If you write the complementary solution of this, that will be c1 cos x plus c2 sine x. Okay, its complementary solution will be this. If you are not aware of that how to find this, then please go and check the previous video. Otherwise, I'll put the link in the description box. So here, along with C1, we have first function that is cos x, and along with C2, we have second function sin x. So these are actually the independent solutions. Okay, so whatever you will have along with the constant in your complementary solution, that are actually independent solutions. Now next point is, if we substitute the complementary solution in higher order differential equation with constant coefficient, we will get 0. For example, see, if instead of this equation, if I have e power x here, let's say we have e power x here, and this is my complementary solution. Okay, obviously if you put this solution here, then if you take y is equals to this and if you put this here, you are not going to get e power x. What you are going to get, if you place this y here, you will get d square y over dx square plus y equals to 0. Okay, because requirement of constants are fulfilled by the complementary solution, and whatever you have on the right hand side, that is actually covered by the particular integral. Okay, I'm repeating here that if you are having any complementary solution, if you substitute that in your equation, you are not going to get the right hand side. Okay, because the requirement of arbitrary constants are covered by the complementary solution, and whatever the function you have on the other side, that is covered by the particular integral that we'll see in the next point. So the next point is, if we substitute the particular integral in the higher order differential equation, we will get the function which is on the right side, which I have already explained. Okay, otherwise we'll see these points in the next slide also. Moreover, the complete solution of the higher order differential equation with constant coefficient is actually equals to complementary solution plus particular solution. Okay, now see this on next slide. Now just to explain these points, I'm going to take the same example. So d square y over dx square plus y equals to e power x. Now here on the other side, we are not having 0. So your particular integral will not be 0. Okay. So your complete solution will be equal to complementary solution plus particular integral. Okay, if you are not aware of that how to calculate complementary solution and particular integral, you can check the videos. I'll put the links in the description box. Okay, so here your solution will be, complementary solution is c1 cos x plus c2 sin x. Okay, and your particular integral will be 1 by 2 e power x. All right, now these two are the independent solutions. Okay, independent solution along with the constants. Okay, because order of this equation is 2, so you must have two constants, and yes, we are having two constant. One is this, another one is this. Okay, we have same number of independent solution. Yes, we have one independent solution is this, another is this. Now if I take this as the solution, what will you get? So what is dy over dx here? If I take, let me clear this. If I take y is equals to, let me write it here. If I take y is equals to c1 cos x plus c2 sin x, this is just a complementary solution. If I don't take this particular integral, what will you get? Dy over dx will be c1 minus sin x plus c2 cos x, right? What will be d square y over dx square? D square y over dx square will be minus c1 cos x plus c2 into minus sin x, right? Now if I substitute this here, what will you get? So here d square y over dx square is what? This one, minus c1 cos x minus c2 sin x. And what is your y? Y is this one. Okay, so if you take this, you'll get c1 cos x plus c2 sin x. So we are getting 0, right? This will be cancelled with this will be cancelled with this. We are getting 0. We are not getting e power x. Okay, so how you'll get e power x? That you'll get from here. Okay, now let's check whether we are getting e power x or not by taking 1 by 2 e power x here. Now if I take y is equals to e power x over 2, what will be your dy over dx? Dy over dx will be e power x over 2. What will be d square y over dx square? that will again e power x by 2, right? Now if I place this here, what you'll get? So this is e power x by 2 plus e power x by 2. So what we are getting? 2 e power x by 2. 2 to cancel e power x. What is this? This is your right hand side. So while putting this particular integral, you will get the things which is on your right hand side. Getting my points? And if I take the complete solution, if I take the complete solution means this one, and if I take dy over dx, and if I take all the things here, then you'll get minus e1, this is sine x, plus c2 cos x, plus 1 by 2 e power x, d square y over dx square, that will be minus e1 sine, cos x, plus c2 minus c2 sin x plus 1 by 2 e power x. Now if you substitute this value here and y here, you will get e power x. Alright, but if you put this complementary solution and particular integral separately, for complementary solution you are going to get 0. Okay, and if you substitute this, you will get the right hand side. Okay, so let's check. So if I place this value here, so what you'll get? Minus c1 cos x minus c2 sin x plus 1 by 2 e power x. And what is your y? Y is this one. Y is this one. This complete. Okay, thing. So here c1 cos x, c2 sin x, and plus e power x by 2. So this will be cancelled with this. This will be cancelled with this. If you add this, what you'll get? 2 e power x over 2, 2 to cancel e power x. This is your right hand side. Okay, so this is your complete solution which is satisfying your equation. So the requirement of arbitrary constants are fulfilled by the complementary solution, whereas the function which is on the right hand side, that you'll get from the particular integral. Okay, so particular integral is free from the arbitrary constant. There is no arbitrary constants. Okay, so this was all about the facts which is important to know for this differential equation. Thank you very much. I'll see you in the next video.